This is Sachin Patil. I am going to present Introduction to Embedded System Shibu KV book, Chapter 4, Embedded Systems, Application and Domain Specific. This Chapter 4 has two concepts to explain, to learn. First, example, washing machine as an application of embedded system, that is a specific application, and automotive car, which is an example for a domain specific, the automobile domain, that is the example is given explained in detail. So, what are the things we are studying in this, learn from this chapter? So, first we learn domain and application specific aspects of embedded system, and then we learn what is a specific application example, that is a washing machine is explained with much more details. And as a domain aspect of embedded system, as an example, automated car is explained with the different control units, that is a high speed control unit or a low speed control unit, and even we learn the few protocols like a CAN, lean and most along with this. So, the embedded systems are application and domain specific, that they built for a certain application in a certain domains like consumer electronics or telecom, automotive or industrial control. So, first example, that is for specific embedded system as an application, washing machine. So, washing machine is a typical example for an embedded system providing a sensitive support in home automation appliances. And this embedded system, that is washing machine, is built around the microcontroller, and at the same time it contains sensors, actuators, a control unit, and then keypads. Just have a look at this slide. This slide will give this figure will give the clear idea the functional blocks of a washing machine. And a washing machine has first the drum, or what you call a tub. There are two tubs, inner tub and outer tub. Outer tub protects the inner tub. In inner tub we will put the cloths for washing, and this washing machine has supplied water by the water inlet, and it is water input is controlled by this valve. Just have a look at the screen or a slide where I am pointing the cursor, and there is one outlet, water outlet, and this is also controlled by a valve and body case to protect all these units. And then the temperature sensor is kept at the bottom, and at the top level there is a level sensor for water level indicator. And apart from this, integrated control panel is provided for the user of this washing machine, that for user interface, and that user interface has a LED display in it, and then keypad, and at the background this embedded system, what the control unit what is working in the washing machine built around the system core and a memory, in sensors, actuators and communication interfaces. So, this will better explained with much more detail. So, some of them are visible for us the controller and some of them invisible, and where the actuator a part of the washing machine that I told you that there are sensors and actuators. There are two sensors here, the actuator in the sense this valve and the motor which is used to turn the drum to wash the cloths. So that's a integrated control actuator part of a washing machine consists of motorized agitator and tubes and water drawing input that is called the inlet, outlet. Sensor part consists of water temperature sensor and a water level sensor, and the control part as I explained, this embedded control unit is built around the processor. So that is a control part is as usual, it is a processor or a controller based board which interfaces the sensors and actuators and sends the control signals for function implementation. That's what is washing machine function implementation. Sensor data is fed back to the control unit, and the control unit generates the necessary actuator outputs. Control unit, for example, if the water level sensor will that detects the water has reached to a maximum level, then it will send the signal to the interrupt signal to the microcontroller, and immediately the microcontroller will give the command actuator is activated, the valve inlet valve is made off. Then control unit, the control unit provide connectivity to the user interface, keyboard and setting washing time, selecting the type of material to be washed, light, heavy, medium, etc. User feedback is reflected through the display unit, that is usually LCD or LED unit. Integrated control panel, that is integrated control panel has a microcontroller based IO interface and a control algorithm running on it. The input interface, the user what the input will give. So user is provided the keyboard, and whatever the selection he will do, input he will give, it is just displayed on the screen display. The wash type selected, namely wash, spin, rinse, and the cloth selected light, medium, heavy, and the time selector will provide you half an hour, 15 minutes, half an hour, 1 hour or 2 hour, like that it will give the timing. The output interface consists of that is LED, LCD as you have seen in the diagram, and then this interface may vary from manufacturer to manufacturer. That is what such a standard washing machine interface what is explained as an example here. And at the same time the other type of IO interfaces which are invisible to the end user are different kind of sensors, namely water sensor or level sensors, actuators are present inside. They are invisible, but they are actively involved in making the this embedded product, that is washing machine. That is given as an example for a specific application of an embedded system. Next in a list we see the we have a look at the next example as an automotive domain wise. There are domains, automotive domain, a DSP domain, like that. So they have given the example automotive domain. Then in automotive domain we are controlling the automobile industry car. We take as an example where the car controls the instrument icons on the cruise, and then engine control, fan, control for heating cooling purpose what the fan is used, that fan control, fuel injection control, headlamp control, then ABS anti-brake anti-lock brake system control, wiper control, that is suspension control, then centralized locking, power windows, mirror control, seat adjustment control, airbag, power steering, air conditioner, or even much more that units. If it is, it's basically top end models will come with all these control unit, and even much more than this also can be of the control units are also incorporated in this. Automotive embedded system are the one where the electronic take the control over the mechanical system. So, where with the vehicle vary from simple mirror or a wiper control to, and the complex operations control units are also designed, and they are tagged or interconnected via protocols, bus protocols. That is a complex airbag control and anti-lock brake control also controlled in the automobile industry. So, automotive embedded systems are normally built around the microcontroller, that is what you see here in the block diagram. So, always there is a core, all the embedded control units are built around the core. Either it core may be a microcontroller, most of the time it is microcontroller and microprocessor. It is interfaced with the input sensors and output sensors, then communication interfaces, and at the same time memory, embedded firmware, and other supporting integrations. So, sensors and actuators play a very important role in most of the embedded control units. The electronic control unit used in automobile embedded industry can broadly classified into two types. There are high speed electronic control unit HECU and low speed electronic control unit LECU, where the high speed control units are deployed in a critical control units requiring for fast response. For example, fuel injection system or anti-lock brake systems of the cars or automobiles, and then low speed electronic control units have deployed in the response time is not so critical. So, for example, door lock, central lock system, even small delay or audio control systems, even some small delay is not going to do any much harm to that system. But in case when anti-lock brake systems, very fast response is required, or airbag, you can say that's a very fast response is required by that control unit or control system. That's why there are two, the total control units are categorized into two parts. Then is one is high speed control units, where that control units or embedded control units will very fast in response, and second one is a low speed electronic control units, that response time is sometime maybe have some delays, but it's not so critical. Next, the automobile applications use a serial bus for communications, and the very most popular serial buses which are used, bus protocols which are used in automobile are controller area network, that usually we call that as a CAN, well known as a CAN. It is developed by Robert Bosch. So, then next is a local interconnect network, lean, media oriented system transport, most bus, etc. are the more important automobile communication buses or bus protocols. So first one in this list is a CAN, a controller area network, originally proposed or developed by Robert Bosch. And the Robert Bosch is the company which is a pioneer of automobile embedded solution. And this bus protocol supports for LECU, HECU, high electronic control units. So that is that supports maximum speed of 125 kbps and a high speed of 1 mbps data transfer. An event driven protocol interface with the support of error handling in data transmission. And this kind of bus protocols were very useful in using it in anti-lock brake systems and navigation systems like GPS, and even in engine control it is most useful. So next, another type of protocol what is used in automobile industry is LIN, that is a local interconnect network. This is a single master and a multiple slave bus protocol, and where the maximum of to 16 slaves node can connect to the master. So LIN is a low speed and it supports 20 kbps data rate, mainly used for sensor and actuator interface. The master communication triggers the triggering technique to eliminate the possible bus arbitration problems are used in this. LIN is a bus protocol which are used in the applications for like mirror control, fan control, seat position control, window controls, and a position control where the position where the response time is not a critical issue. So next in this list of the most popular one is a protocol which is used for bus is a media oriented system transport. It's called the MOST, and MOST it is used in automotive industry, automotive audio and video equipment interfaces. So most bus specific is defined the physical layer as well as the application layer or network layer and a media access layer, and which is used for audio and video equipment interface. So this finishes chapter number 4, where we have just gone through the two applications. One is a specific application, another one is a domain application of an embedded system. So thank you for watching the video. Please, if you like this video, press the like button and subscribe. Thank you.